The Soviet Union built aircraft that often looked impossible even on paper. Nuclear-powered bombers, flying tanks, orbital spaceplanes, and machines so large American satellites mistook them for warships. This is every Soviet and Russian experimental aircraft ever built. 1. TS-ANT-4, TB-1, Soviet Union, 1925. The ANT-4 was not simply a bomber. It was an argument. Designed by Andrei Tupolev at the Central Aerohydrodynamic Institute, it became the world's first cantilever all-metal monoplane heavy bomber, a low-wing, twin-engine design with no external bracing wires and no biplane configuration, just a structurally confident, clean wing carrying its own weight. It predated comparable Western designs by nearly a decade. In a single aircraft, Tupolev's bureau announced that Soviet aviation would not follow the world. In certain directions, it would lead it. 2. Kalinin K-7, Soviet Union, 1933. Konstantin Kalinin's K-7 was one of the most radical structural concepts of the interwar period. Its near-flying wing fuselage, 6 tractor engines along the leading edge, a 7th pusher engine at the rear, and twin tail booms extending behind the wing created a configuration that no other engineer had seriously attempted at such scale. It flew, but structural resonance in the tail booms proved fatal. On its 7th flight in 1933, a boom failed and the aircraft crashed, killing 15. The K-7 was canceled, but it demonstrated that Soviet designers were willing to attempt configurations Western aviation had not yet imagined, and willing to pay the cost of that ambition. 3. Vakhmistrov Zveno, Soviet Union, 1931 to 1941. Vladimir Vakhmistrov's Zveno project answered a question that seemed absurd. Could a heavy bomber carry and launch fighter aircraft in flight? After years of experimentation using TB-1 and TB-3 bombers as airborne carriers, the answer was operationally confirmed in 1941 when I-16 fighters launched from a TB-3 destroyed a Romanian bridge over the Danube. The Zveno was the world's first operational composite aircraft system, a concept that would resurface in American thinking about air-launched drones decades later and remains conceptually relevant in discussions of modern hypersonic delivery platforms. 4. TSAGI-1EA, Soviet Union, 1930. Boris Chermukhin's TSAGI-1EA was the Soviet Union's first practical helicopter, using a coaxial counter-rotating rotor arrangement to manage torque without a tail rotor. In 1932, Chermukhin flew it to 605 meters, a world altitude record for rotorcraft, never officially recognized because the Soviet Union was not yet a member of the FAI. The coaxial rotor philosophy Chermukhin demonstrated here would return decades later as a defining characteristic of the entire Kamov helicopter lineage, naval, reconnaissance, and attack variants that served the Soviet fleet across the Cold War. 5. Nikitin Shevchenko IS-1, Soviet Union, 1940. The IS-1 was built around one question. Could a biplane become a monoplane in flight? Mikhail Nikitin and Vasily Shevchenko designed the IS-1 with retractable lower wings. Once airborne, the pilot could fold the lower wing into the upper, converting a high-lift biplane into a clean, fast monoplane. The logic addressed a genuine tactical conflict. Biplanes offered short takeoff performance and low-speed agility, while monoplanes offered speed. The IS-1 attempted to give a pilot both in the same airframe on demand. It was tested successfully and remains one of the most mechanically inventive solutions to a real operational problem in the history of pre-war aviation. 6. Berezhnaya BI-1, Soviet Union, 1942. On May 15, 1942, the BI-1 became the Soviet Union's first rocket-powered aircraft. Its liquid fuel engine, burning a caustic propellant mixture designed by Isayev and Dushkin, generated thrust that no piston engine of the era could approach. Conceived as a rapid-climb point defense interceptor to destroy German bombers over Soviet cities, it was fast, violent in its acceleration, and extremely unforgiving. In 1943, test pilot Grigory Bakhchivandzhy was killed when the aircraft entered an unrecoverable dive near transonic speed, an encounter with compressibility that Soviet engineers did not yet fully understand. The BI-1 program ended. Soviet rocket propulsion research did not. 7. Lavochkin La-250 Anaconda. Soviet Union, 1956. The La-250 was one of the most troubled programs in Soviet aviation history. Designed as a supersonic long-range interceptor against American strategic bombers, it was nearly 27 meters long, powered by 2 afterburning turbojets, and deeply unstable. Pilots described it as genuinely uncontrollable at certain flight conditions. Multiple prototypes were lost. The program was abandoned, and it became one of Lavochkin's final manned aircraft before the Bureau shifted entirely to missiles and space systems. Its failure was a precise reminder that aerodynamic ambition without adequate computational stability analysis had consequences that no amount of courage in the cockpit could overcome. 8. Myasishchev M50 Bounder. Soviet Union, 1959. Vladimir Myasishchev's M50 was the Soviet Union's most serious attempt at a supersonic strategic bomber. An enormous delta-wing platform with 4 turbojets, 2 underwing, 2 on wingtip pylons. It represented the full ambition of Soviet strategic aviation at the dawn of the missile age. It flew once publicly at the 1961 Tushino Air Show, before Khrushchev's doctrine of missile primacy canceled the program and dissolved Myasishchev's bureau into Tupolev's organization. The M50 endures as a monument to an era when Soviet bomber ambition was ended not by technical failure, but by a political decision that redefined what strategic power meant. 9. Sukhoi T-4 Saka. Soviet Union, 1972. The T-4 was perhaps the most technically advanced aircraft the Soviet Union ever flew. Designed to reach Mach 3 at altitude, penetrate NATO air defenses, and strike American carrier battle groups with unstoppable speed, it demanded entirely new manufacturing processes in titanium and steel to withstand aerodynamic heating. Its fly-by-wire flight control system was among the first in Soviet aviation. It flew 14 times before the program was canceled, reportedly under institutional pressure from Tupolev's competing Tu-22M program. The T-4 flew to Mach 1.28 before it was stopped. What it might have reached remains one of the most debated questions in Soviet aviation history. 10. Tupolev Tu-144. Soviet Union, 1968. The Tu-144 flew before Concorde. Its maiden flight on December 31, 1968, 2 months ahead of the Anglo-French aircraft, made it the world's first supersonic passenger aircraft by the calendar. But the gap between first flight and operational maturity was painful. Engine reliability problems, aerodynamic compromises, and a catastrophic crash at the 1973 Paris Air Show defined its public legacy. It entered limited Aeroflot service in 1977, but was withdrawn within a year. Its second chapter came quietly in the 1990s, when NASA funded the use of surviving Tu-144 airframes as supersonic research platforms, an unlikely collaboration between American scientists and a machine born from Cold War prestige competition. 11. Mikoyan E-166. Soviet Union, 1961. The E-166 was a purpose-built speed record aircraft derived from an enlarged MiG-21 airframe, fitted with a single high-thrust Tamansky turbojet pushed to maximum output. In 1961, it set an absolute air speed record of 2,681 kilometers per hour, a record that stood for several years. The Soviet Union presented it under its record designation rather than its military lineage, deliberately obscuring its relationship to the MiG family. What the E-166 demonstrated, beyond the record itself, was that the aerodynamic platform underlying the MiG-21 carried significant untapped performance the production fighter was never fully configured to exploit. 12. Tsybin RSR. Soviet Union, 1959. Pavel Tsybin's RSR, Reaktivny Strategiki Razvedchik, jet strategic reconnaissance aircraft, was designed to fly at Mach 2+ at altitudes beyond the reach of any interceptor. Long, slender, and carefully area-ruled to minimize wave drag at supersonic speed, it reflected a thorough grasp of high-speed aerodynamics that few Soviet bureaus outside TSAGI had demonstrated. The program was canceled when the Tu-22 absorbed its reconnaissance mission, but the RSR represented an aerodynamic capability from a bureau that rarely received the recognition its technical output deserved. 13. Tupolev Tu-123 Yastreb, Soviet Union, 1964. Built on the technical foundation of the cancelled Tu-121 cruise missile program, the Tu-123 Yastreb, Hawk, was an unmanned supersonic reconnaissance drone capable of Mach 2.5 at over 22,000 meters. It was ground-launched on solid fuel boosters, flew its mission autonomously, released its film capsule for aerial recovery, and then crashed. The airframe itself was considered expendable, operating at altitudes and speeds no interceptor of the era could reliably engage. The Tu-123 gave Soviet commanders a strategic reconnaissance capability that was genuinely difficult to counter. It was operational for over a decade and remains one of the most serious unmanned reconnaissance systems of the early Cold War. 14. Bartini VVA-14, Soviet Union, 1972. Roberto Bartini, the Italian communist émigré who became one of Soviet aviation's most original thinkers, designed the VVA-14 as a vertical takeoff amphibious aircraft capable of operating in ground effect over open water. It was an extraordinary hybrid, a catamaran hull fuselage flanked by inflatable pontoons, a high-mounted delta wing, and initially intended to use lift jets for vertical takeoff before transitioning to cruise flight in ground effect near the water surface. Only 2 prototypes were built. The vertical takeoff system was never installed due to engine availability problems. But the aerodynamic and structural thinking embedded in the VVA-14 influenced the Ekranoplan programs that followed and remains one of the most visually striking aircraft ever built by any nation. 15. Ekranoplan KM, Soviet Union, 1966. In 1966, American reconnaissance satellites photographed something crossing the Caspian Sea at nearly 500 kilometers per hour. It was enormous, close to 100 meters long, and it barely left the water's surface. CIA analysts called it the Caspian Sea Monster. Soviet engineers called it the KM Korabl Maket, or ship prototype. Designed by Rostislav Alexeyev, the KM weighed 544 tons and flew on 10 turbojets by exploiting ground effect. The aerodynamic cushion formed between a large wing and a flat surface at very low altitude, where induced drag collapses and lift efficiency rises dramatically. It was not quite an aircraft and not quite a ship. It operated in a physical regime that no other vehicle in history had explored at that scale. 16. Luan-class Ekranoplan, Soviet Union, 1987. The Luan Harrier was the most militarily aggressive Ekranoplan ever constructed. Armed with 6 SSN-22 Sunburn anti-ship missiles in launch containers mounted above the fuselage. It was designed to attack NATO carrier battle groups at very low altitude and very high speed, below radar horizon, with weapons among the fastest anti-ship missiles then in existence. Only one operational example was completed. It now rests on land in Dagestan, partially restored. The single most powerful ground effect vehicle ever built, a weapon system with no direct counterpart in any other nation's arsenal. 17. Myasishchev M-17 Stratospheric, Soviet Union, 1982. The M-17 was designed for a mission that sounds almost anachronistic: the destruction of American high-altitude reconnaissance balloons drifting across Soviet territory. But the engineering it required was anything but simple. Operating above 20,000 meters demanded a long, straight, high aspect ratio wing that generated sufficient lift in air thin enough to offer almost no resistance, a configuration closer to a powered sailplane than a military aircraft. The M-17 Stratospheric capability eventually outlasted its original mission entirely. Its evolved successor, the M-55 Geophysica, was used by European Space Agency researchers for stratospheric ozone and aerosol studies, a Cold War interceptor repurposed for climate science. 18. Mikoyan MiG-105 Spiral, Soviet Union, 1976. The MiG-105 was the Soviet Union's answer to a question that the United States was also asking in the 1960s. Could a piloted spaceplane be launched from the back of a supersonic aircraft, enter orbit, perform a military mission, and return to Earth for a runway landing? The Spiral program, from which the MiG-105 emerged as the atmospheric test vehicle, was a serious space combat concept that predated the American Space Shuttle by years in its conceptual development. The MiG-105 stubby, lifting body adjacent fuselage and folding wings were designed for hypersonic re-entry aerodynamics. It was flown subsonically from 1976 to 1978 before the program was terminated in favor of the Buran shuttle concept. Its aerodynamic data fed directly into Russia's understanding of hypersonic re-entry vehicle design. 19. Buran orbital spaceplane. Soviet Union, 1988. Buran Snowstorm flew exactly once, unmanned, on November 15, 1988, completing 2 orbits of Earth and landing autonomously with a precision that exceeded NASA's expectations for the space shuttle. Visually similar to the American shuttle, Buran was aerodynamically distinct. Its automated landing system was more capable, its thermal protection tiles were of different composition, and its design incorporated lessons from Soviet re-entry vehicle research that had no American parallel. The program was canceled after the Soviet collapse. The sole flown orbiter was destroyed in 2002 when the roof of its storage hangar at Baikonur collapsed. What was lost was not just a spacecraft. It was the culmination of 2 decades of Soviet research into hypersonic aerodynamics, re-entry heating, and autonomous flight control. 20. Sukhoi Su-47 Terminator, Russia, 1996. The Su-37 was the most extreme evolutionary form of the Su-27 airframe, a thrust-vectoring demonstrator that pushed post-stall maneuverability beyond any boundary previously explored. Its 2 AL-31FP engines with deflectable nozzles allowed the aircraft to point its nose in directions entirely decoupled from its flight path, performing sustained maneuvers at near-zero airspeed that no infrared missile seeker of the time had been designed to track. Full 360-degree somersaults, tail slides, controlled flight at angles of attack that would have caused any conventional aircraft to depart. The Su-37 flew as a single prototype, but its thrust vectoring technology passed directly into the Su-35S and the Su-57, the 2 most capable combat aircraft Russia currently operates. 21. Sukhoi Su-47 Berkut, Russia, 1997. The Berkut Golden Eagle arrived with one of the most visually arresting configurations in aviation history: forward-swept wings. The aerodynamic case for forward sweep is real lift distribution patterns, improved maneuverability at high angles of attack, and the design generates favorable aerodynamic twisting moments during pull-up maneuvers. But forward-swept wings also generate structural divergence forces that bend outward rather than inward, threatening to destroy the wing unless resisted by advanced composite materials. The Su-47 solved this with carbon fiber structures. It flew as a research aircraft throughout the late 1990s and early 2000s, and its aerodynamic influence is traceable in the wing and inlet geometry of the Su-57. 22. Mikoyan 1-44 MFI, Russia, 2000. The MiG-1-44 was Russia's 5th-generation fighter candidate, the design that should have competed with the Su-57 for the PAC-FA contract. Featuring canards, a delta wing, internal weapons bays, and the beginnings of radar-absorbent structure, it was conceived in the late Soviet period and first flown in February 2000. It flew only twice before funding collapsed. The MiG Bureau had staked its institutional future on this aircraft. When the contract went to Sukhoi, the 1.44 became as much a symbol of post-Soviet industrial collapse as an aviation milestone, the moment when one of the most famous fighter design bureaus in history effectively lost its relevance in the combat aircraft market. 23. Tupolev Tu-160 Blackjack Prototype, Soviet Union, 1981. The Tu-160 prototype, which first flew in December 1981, was the culmination of Soviet variable geometry strategic bomber development, the largest and heaviest combat aircraft ever built, with a maximum takeoff weight exceeding 275 tons and a top speed above Mach 2. Its swing wing configuration allowed it to operate at low altitude in subsonic terrain following mode and transition to high-speed supersonic dash for penetration. The prototype program required new approaches to airframe sealing, structural fatigue management at variable sweep angles, and NK-321 engine integration. The Tu-160 entered service in 1987 and remains in Russian Aerospace Forces service today, representing the last expression of the Soviet supersonic strategic bomber philosophy. 25. Grokhovsky G-38. Soviet Union, 1934. Pavel Grokhovsky occupied a singular space in Soviet aviation, part engineer, part visionary, occasionally dismissed as both. His G-38 was an experimental tailless flying wing glider, intended to explore the aerodynamic behavior of configurations without conventional tail surfaces. Grokhovsky's bureau produced dozens of unconventional designs through the 1930s, and the aerodynamic data gathered from the G-38 and similar vehicles fed Soviet interest in all-wing configurations that would resurface in stealth aircraft research half a century later. Grokhovsky himself was arrested during Stalin's purges, but his ideas proved harder to imprison than the man. 26. Cheranovsky Bitch-20. Soviet Union, 1936. Boris Cheranovsky spent his career obsessing over one configuration, the parabolic flying wing. His Bitch-20 was a tailless, all-wing glider with a curved, parabolic platform that he argued possessed natural stability advantages over conventional designs. Cheranovsky flew his designs himself, accumulating empirical data that no computational tool of the era could generate. His work influenced Soviet research into tailless aircraft and contributed to the theoretical base from which later delta and blended wing designs were developed. He is almost entirely unknown outside specialist aviation history circles, but his aerodynamic philosophy was decades ahead of mainstream acceptance. 27. Sukhoi Su-54, Russia, 2002. The S-54 was a lightweight single-engine technology demonstrator developed by Sukhoi in the early 2000s to explore agile fighter aerodynamics at lower cost than a full-scale prototype program. With a configuration resembling a scaled-down Su-57 predecessor, it evaluated fly-by-wire control law refinements, reduced signature structural concepts, and airframe integration approaches that the Bureau was developing for its fifth-generation program. The S-54 was never publicly confirmed in detail and operated largely outside Western awareness, but it represented the final layer of aerodynamic verification that preceded the T-50 prototype's first flight in 2010. 28. MiL V-12 Homer. Soviet Union, 1968. The MiL V-12 was the largest helicopter ever built, not by a small margin, but decisively. With a side-by-side twin-rotor configuration on outrigger pylons spanning 67 meters, it was powered by 4 turboshaft engines and capable of lifting payloads that fixed-wing transport aircraft of the era could not match from unprepared surfaces. In 1969, it set a payload-to-altitude world record that has never been broken by a rotorcraft. The V-12 was designed to deliver ballistic missile components to remote Soviet launch sites inaccessible by road. Only 2 prototypes were built. The logistical problem it was designed to solve was eventually addressed differently, but the V-12 remains the absolute outer boundary of what rotorcraft engineering has ever physically achieved. 29. Kamov Ka-22 Vinterkryl. Soviet Union, 1960. The Ka-22 Vinterkryl rotor wing was a convertiplane, a hybrid vehicle with both rotors for vertical takeoff and propellers for forward flight, bridging helicopter and fixed-wing performance in a single large airframe. In 1961, it set world speed and payload records for rotorcraft, but it was mechanically complex, and 2 fatal crashes during the test program, both attributed to control system failures in the rotor-to-propeller transition regime, ended its development. The Ka-22 demonstrated that the convertiplane concept was aerodynamically viable but mechanically unforgiving, a lesson that V-22 Osprey engineers decades later would learn independently through their own development process. 30. Sukhoi Su-47 T-50 prototype, Russia, 2010. When the T-50 lifted off from Komsomolsk-on-Amur on January 29, 2010, it carried the accumulated weight of Soviet and Russian experimental aviation across nearly 9 decades. Designed for supercruise, internal weapons carriage, advanced sensor fusion, and supermaneuverability through 3-dimensional thrust vectoring, the Su-57 drew its aerodynamic DNA from every program in this documentary. From Sukhoi's swept-wing research of the 1940s, through the T-4's fly-by-wire legacy, through the Berkut's composite structures, through the Su-37's vectoring nozzles. Its design reflected Russian aerodynamic doctrine rather than imitation of Western precedent. It entered limited service in 2020 and represents the living conclusion of a century of Soviet and Russian experimental ambition. If you enjoyed this video, don't forget to subscribe. And if you noticed any mistakes or inaccuracies, please let me know in the comments below.